assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So we know that from the highest level to the lowest level, this is going to be twice the amplitude or the maximum displacement of motion. Therefore, we also know that the period is related to the angular frequency by equation 15.5. So we can say that first, the maximum displacement is going to be equal to half of the distance described in the problem. And then we know that the angular frequency is going to be 0.503 radians per hour. At this point, we can say that the phase constant, phi, is going to equal 0. And this is from equation 15.3. And this is because we are starting our clock when the initial displacement is the maximum displacement. So we can solve for t when x is 1/4 of the total distance from the highest to the lowest level, or essentially half the distance from the highest level to the middle level. We can solve for t when the ocean surface is at x equaling 1/2 times the maximum displacement, or 1/4 of the distance described in the problem. We know that the general equation, x equals the maximum displacement times cosine of omega t plus phi. So therefore, we're going to obtain that 1/4 d is going to be equal to 1/2 d multiplied by cosine of 0.503 t. Remember here, t would be measured in hours plus 0. And so we're essentially obtaining 1/2 equaling cosine of 0.503 t. And then t is essentially going to be equal to arc cosine of 1/2 divided by 0.503, and t is going to be 2.08 hours. This would be our final answer. Remember to have your calculator in radians mode and not degree mode. So again, remember when you're solving for this, when you're solving for t, always have your in radians mode. Your final answer is again 2.08 hours. That is the end of the solution. Thank you for watching.